Alright, so in this video we will be looking at how do you convert a given logic circuit to a logic expression. Okay, so the idea is that we will be provided with a circuit like this over here, and we have to convert this entire circuit into a kind of an equation, let's say. Okay, now in order to do this, in order to convert from logic circuit, a given logic circuit, to logic expression, which we will do over here, we need to follow three simple steps. Let's focus on this example first. So the first thing we are going to do is label each output, label each output in this circuit. Okay, so the first step is really just remember label. Okay, the first step is label. All right, each output. All right, so each of the gates that you see over here, the wires that are coming into these gates are the inputs. Okay, and the wires that are going out of any gate is the output. Okay, so when I say label each output, what I really mean to be asking is, look at each gate, and on the right hand side of the gate, label that wire with a letter. Okay, now since A, B and C are already used over here, I will be using D for this side and E for this side. For the last gate, X is already written for us. That will always be the case. Okay, so you don't need to label that, or maybe just use X for that. Okay, so this is the first step. We label each output like this: D, E and X, and this needs to be done right after each gate gives an output. Okay, so this output is of this gate, we label it as D. This output is of this gate, we label it as E. And then this output is of this gate, we label it as X. All right, the next step is to write down an expression for each label. Okay, now how are we going to do that? What do we mean by that? So first of all, each of the labels that I had written over there, I will copy them down over here: D, E and X. Okay, the next thing I'm going to do is I write down equals to in front of these. Okay, and here's what I'm going to do. I'm going to look at what gate was there before this label, and if you see before D, what gate is this? You should be able to recall what kind of gate this was. Okay, this is an AND gate. Okay, and then look at what inputs were going into that gate. Okay, so look at the gate and the inputs that are going into that gate. This is an AND gate, and the inputs that are going into it are A and B. Okay, so we will write down A and B over here. Okay, now for the other input, for the other output E, what gate is that? This is a NOT gate. Okay, and then of course after the gate you look at what input was going into it. It's the C. Okay, so how do we write down this kind of expression? Well, the gate was NOT, right, and the input was C. And remember, NOT gate is the only one that has just exactly one input going into it, right? Now the last one is this one, right? What gate is this? It looks like an AND gate, but then there is a dot in the front, which means it is a NAND gate, right? So this is a NAND gate. And now we will look at the two inputs that are going into this gate. What were these inputs? It is D and it is E, right? So we're going to copy those inputs over here, D and NAND E. All right, now so we are done with the first two steps. We simply labeled the outputs in the first step, and then we wrote down expressions for each label like this over here. Now for the very last step, we have to replace labels for X, and the final answer should have only letters A, B and C. Okay, so we see the expression for X over here. Do we have any A, B, and C over here? No, we don't. So we need to replace the labels for X. Now, how are we going to do that? Well, for that purpose, what we are going to do is simply look at D over here, for example. Now, if you notice, we already have an expression for D, right? So what we are going to do is we will copy the same expression, but in place of D, we will make a bracket, and in place of D, I will replace it with whatever D is equal to. Okay, D is equals to A and A and B, right? This whole thing, remember, this whole thing is just the replacement for D. Okay, I mean use a different color for this. So D gets replaced by this whole expression. Why is that the case? Because D was equal to A and B. Okay, so it's justifiable to replace D with A and B, right? What was written after D in our expression? It was NAND, so we will copy that, NAND. Then we will look at the other letter, which is E over here, right? And again, we will ask ourselves that same question. Do we have an expression for E? Well, we do have. E is equal to not C, right? So we can replace E with that particular expression, right? So E is simply replaced by not C. Okay, and this is our final answer. Okay, so remember that D was then replaced by A and B, and E was replaced by not C. Once we while we were doing that, we had to provide brackets around it, which is compulsory. Okay, why was D replaced by A and B and E was replaced by not C? Because D was equal to A and B, so it is like justifiable. It is all completely fine if you just replace D with something that represents D. Okay, this expression represents D. All right, so this is going to be our final answer. Let me just write it down without all the highlighters and everything. So our final answer is this: X is equals to A and B, NAND not C. Okay, that is our final answer.